So in this question, we're shown a curve which has the equation y equals f of x, where f of x is equal to 4 sine x over e to the power of root 2 x minus 1. So we're told that the curve has a maximum turning point, which we can see here at P, and we're told it has a minimum point, which we can see here at Q. So now let's take a look and see what this question wants us to do. So for part A of this question, we're asked to show that the x-coordinates of point P and point Q are solutions of the equation tan 2x is equal to root 2. So let's get going with this question. So we know f of x, it's 4 sine 2x over e root 2 x minus 1. We know that P and Q are turning points, they're maximums and minimums. So we know that when we have a turning point like that, we know this is called a stationary point. So we then think we have a stationary point, a minimum point, a maximum point. So what should we do here? So what we can say is we'll have a stationary point when the derivative of f, so f dash of x, is equal to 0. So in other words, when f dash of x is equal to 0, we're going to have a stationary point. So we now take a look at f of x. So we have something divided by something else. So we know to differentiate this, we want to use the quotient rule. So we recall that the quotient rule to find f dash x is going to be the derivative of the numerator multiplied by the denominator, and then we subtract the numerator multiplied by the derivative of the denominator, and then we divide that by the denominator squared. So just writing all this down, we can do as follows. So let h of x be our numerator, so that's equal to 4 sine 2x, and then let g of x be equal to our denominator, which is e root 2 x minus 1. So then we can work out the derivative of 4 sine 2x. So using the chain rule and our knowledge of trig differentiation, we know that we'll have 2 times 4, so we'll have 8, and then sine goes to cos, so we'll have cos 2x. And then for the derivative of g of x, we will multiply g of x by the derivative of root 2x minus 1. So we know that that differentiates to give root 2. So therefore the derivative of e root 2 x minus 1 is going to be root 2 and then of g of x. So e root 2 x minus 1. So the next stage is to take the quotient rule formula and substitute these values in. So therefore we can write that f dash of x is going to be equal to 8 cos 2x multiplied by e root 2 x minus 1, and then we'll subtract h of x, so 4 sine 2 of x multiplied by the derivative of g of x, so that will be root 2 e root 2 x minus 1, and then we're going to divide all of this by g of x squared, so e root 2 x minus 1, and we square it. So our next step here, we know that to find the stationary point, we'll set f dash x equal to 0. So let's do that just here. So then what we can do next is if we multiply both sides by the denominator, it will then mean we can clear the denominator because we're multiplying by 0 on this side here. So therefore that leaves us with the following. We're going to have 8 cos 2x multiplied by e root 2 x minus 1, and then we subtract. We can do a bit of tidying up here, so we're going to have root 2 multiplied by 4, so that's going to be subtract 4 root 2 sine 2x, and then we'll have our e root 2 x minus 1 and set that equal to 0. So now we need to have a think and see what we can do next. So what we notice is that we have a common term between this line here. So we have an exponential term on both sides of our equation. So let's take this out as a common factor. So if we take e root 2 x minus 1, Let's take that out, and then here we'll multiply by 8 cos 2 of x, and then on this side it'll be 4 root 2 sine 2x, and that's all equal to 0. So if we then now divide both sides by e root 2x minus 1, we'll then eliminate that from this side, and then this side will remain as 0. So we therefore have now that 8 cos 2x minus 4 root 2 sine 2x, and that's still equal to 0. So what we can do now is equate these two terms. So therefore we're going to have 8 cos 2x is going to be equal to 4 root 2 sine 2 of x. So now let's take a look back at our question. So we were wanting to get this into the form tan 2 of x. So we know, one thing that we can note, we know that tan 2 of x is going to be equal to sine 2 of x divided by cos 2 of x. So therefore, we can now manipulate what we have to get it into a form where we have sine x over cos x. So if we now divide both sides by cos 2x, we're going to have that 8 is going to be equal to 4 root 2 sine 2x, and we divide that by cos 2 of x. So then what we can then do is divide both sides by 4 root 2, which gives us that sine 2x over cos 2x is going to be equal to 8 divided by 4 root 2. So therefore tan 2 of x is going to be equal to, we can now simplify 8 over 4 root 2, that simplifies down to root 2, and this gives us the answer that we are required to show. Tan 2x is equal to root 2. So now moving on to part B of this question, we're asked to use our answer from part A to find the x-coordinates of the minimum turning point of the curve with the equation. Initially we'll do it for y is equal to f2 of x. So when we had that y was equal to f of x, we had that tan 2 of x was equal to root 2. So therefore, we're now going to have 2 times this. So we can therefore say that for y being equal to f of 2 of x, we'll therefore have that tan, then we multiply 2 by 2, which gives us tan 4 of x is equal to root 2. So then to find the x-coordinate, we'll then solve this. So we'll have that x is going to be equal to tan minus 1 of root 2, and we divide by 4. And then in this case, we want to find the second solution, because the first solution will correspond to our maximum turning point. So we therefore add pi over 4. And if we then put this into our calculator, we'll have that x is equal to 1.024. So now for part B of this question, we want to find the minimum turning point on the curve with the equation y is equal to 3 minus 2f of x. So our first thought will be f of x remains unchanged. So therefore, we want to solve tan 2x is equal to root 2. So going ahead and solving this, we'll have that x is going to be equal to tan negative 1 root 2, and since we have 2x, we're going to divide by 2. And putting this into our calculator, we get that this is equal to 0.478. So now you might ask, why did we take the first solution to this? Well, you can see this is a minimum turning point, but then when we scale it and transform the graph by this 3 and negative 2 here, this then changes this into the maximum turning point that we see at point P on the graph. So we'll now take a look back and see where we earned our marks in this question. In part A of the question, there was 4 marks available. We picked up our first mark for attempting to differentiate using the quotient rule or otherwise. So here, when we stated what the quotient rule was, and when we began to show we knew what we were doing with it, we would receive our first mark. We then receive our second mark for getting to this stage here, when we had that f dash x was equal to 8 cos 2x e to root 2 x minus 1, and then we take away 4 sine 2x, multiplying that by root 2 e to the power of root 2 x minus 1 divided by this g of x term squared. That is where we picked up our second mark. We then received our third mark for setting this new f dash x expression. We received our third mark for setting that to be equal to 0. And then we received our fourth mark for doing the algebraic manipulation to then come to the conclusion that tan 2x was equal to 2, which was what the question asked us for. Then moving to part B of the question, it was worth 4 marks in total. So for the first part of the question, we received our first mark for solving tan 4x was equal to 2, and then we receive our second mark for coming to the correct conclusion of x is equal to 1.024. And then similarly for the second part of this question, we receive our first mark for knowing to solve tan 2x is equal to root 2, and then we receive our second mark for coming to the conclusion that x was equal to 0.478.